Why nothing with mass can reach the speed of light.
Science Makes Me Smile, presented by young Dr. JGC, a creation of old Dr. JGC.
I'm young Dr. JGC. Let's begin. Why nothing with mass can reach the speed of light. Imagine a group of scientists deep underground at CERN, guiding tiny particles, protons, around a vast circular track. They push these particles faster and faster, using some of the most powerful machines ever built. At first, everything behaves as expected. Add more energy, the protons go faster. Add even more, faster still. But then something strange begins to happen. The closer the protons get to the speed of light, the harder it becomes to make them go any faster. The scientists keep adding energy, more and more of it, but the speed barely changes. It's as if the protons are resisting, not stopping, but refusing to cross a certain boundary. To understand what was happening, scientists turned to mathematics, not to force an answer, but to describe what they were seeing. One of the first clues came from a famous relationship, E equal to mc squared. This equation tells us something very important. The speed of light, c, is a constant. It does not change. That means the only way for energy, E, to increase is for mass, m, to effectively increase as well. In simple terms, more energy corresponds to more mass. So as those protons gain energy, they don't just speed up. They behave as if they are becoming heavier, making them harder and harder to accelerate. But that still wasn't enough to explain the strange slowdown near the speed of light. That's where a deeper piece of math comes in, from Einstein's theory of special relativity, expressed in the factor as seen in the equation in display. The term v squared over c squared simply compares the object's speed v to the speed of light c. It tells us how close we are to that ultimate limit. If the speed is small, this number is close to zero, and the equation becomes effectively E equal to mc squared.
Understanding this simple math is essential to grasping the entire concept. Take a moment, if needed, to fully understand the equation within the context of the topic.
If the speed gets very close to light speed, the number gets very close to 1e finally reveal itself. As v squared over c squared approaches 1, the denominator in the equation shrinks towards 0. When that happens, the entire expression grows extremely large. Any number over near 0 is extremely large. What this means physically is that the energy required to keep accelerating the particle doesn't just increase, it grows dramatically. Faster requires much more energy. Even faster requires vastly more. And as you approach light speed, the demand rises without bound. To reach the speed of light exactly, you would need infinite energy. And that is the key. No machine, no matter how powerful, can provide infinite energy. So the protons at CERN never quite get there. They come incredibly close, closer than anything in everyday experience, but they always fall just short. What makes this even more remarkable is that these equations were written long before machines like CERN existed. In 1905, based on earlier experiments such as the Michelson-Morley experiment, Einstein developed a theory that predicted this exact behavior, decades before anyone could test it directly with particle accelerators. When those machines were finally built, they did not contradict the theory. They confirmed it. If we take that same equation and simply plot it, we obtain a curve that shows how energy grows as speed approaches the speed of light. The graph rises slowly at first, then more steeply, and finally shoots upward almost vertically as it nears light speed.
In the end, the math didn't invent this limit. The experiments revealed the puzzle, the math revealed the structure behind it, and later experiments confirmed it with extraordinary precision.
Now you know why nothing with mass can ever reach the speed of light. I hope you enjoyed this journey. Let me know what you think in the comments. And as always, thanks for watching Science Makes Me Smile.